Welcome to Introduction to Operating Systems. In this class, we'll explore the fundamentals of OS, including processes, memory management, file systems, and more. Let's dive into the world of OS. An operating system, OS, is the software that manages hardware and software resources on a computer. It acts as an intermediary between users and the computer hardware, making it possible to run programs. The OS is responsible for tasks like memory management, process management, file systems, and device control. For example, when you open a program like a web browser, the OS allocates memory for the program, schedules its execution, and manages input-output operations like loading web pages. Another key concept is multitasking. Imagine you are listening to music and browsing the web simultaneously. The OS divides the CPU's time between these tasks, ensuring they run smoothly. In this course, we'll cover topics like process management, virtual memory, file systems, and security, giving you a comprehensive understanding of how operating systems work. Let's get started. An operating system, OS, is system software that manages computer hardware, software, and resources. It serves as an intermediary between the user and the computer hardware, enabling efficient operation. The OS performs essential tasks such as managing processes, memory, input-output devices, and file systems. For example, when you launch a program like Microsoft Word, the OS allocates memory, processes the instructions, and manages resources like the keyboard and mouse. It ensures smooth operation by multitasking, allowing you to run multiple programs at once. In essence, the OS helps coordinate hardware and software, providing an environment for applications to function properly. Some common OS examples are Windows, macOS, and Linux. An operating system, OS, has several key features that ensure efficient management of computer resources. Process management. The OS manages processes, ensuring they run smoothly without interfering with each other. For example, it allows you to run a web browser and a music player simultaneously. Memory management. The OS allocates memory to processes. It ensures each program gets enough memory without affecting others. For instance, opening a large application, like Photoshop, will trigger memory allocation. File system management. The OS organizes data in files and directories. For example, when you save a document in Word, the OS determines where it is stored. Device management. The OS controls input-output devices like printers and keyboards. For example, when you print a document, the OS communicates with the printer to execute the task. These features enable the OS to maintain stability and performance. Memory management in an operating system is crucial for efficiently allocating and managing system memory. It ensures that each running process gets the memory it needs, while preventing conflicts between processes. There are two key types of memory management: primary memory, RAM, allocation. The OS allocates space in RAM for active processes. For example, when you open a program like a web browser, the OS assigns RAM to store data the program uses. Virtual memory. When RAM is full, the OS uses a part of the hard drive as virtual memory to temporarily store data. For example, if you open many applications, the OS may use the hard drive to store data from less used programs, ensuring system stability. The OS also uses techniques like paging and segmentation to optimize memory usage, preventing issues like memory leaks or fragmentation. Process management in an operating system involves handling the execution of processes, ensuring they run efficiently and without interfering with each other. A process is a program in execution, including its code, data, and system resources. Key aspects of process management include process scheduling. The OS decides which process gets the CPU. For example, if you're running a browser and a video editor, the OS alternates between them, giving each a small time slice. Process synchronization ensures that processes don't interfere when accessing shared resources. For example, if two programs try to write to the same file simultaneously, the OS ensures proper synchronization to avoid data corruption. Process termination. The OS ends processes when they complete or encounter an error. For example, when you close a browser window, the OS terminates the browser process and frees its resources. Effective process management ensures system stability and multitasking. Device management in an operating system involves controlling and coordinating hardware devices like printers, keyboards, and storage drives. The OS acts as a bridge between software applications and hardware, ensuring that devices function smoothly. Key aspects of device management include device drivers. The OS uses device drivers to communicate with hardware. For example, when you connect a printer, the OS uses the printer's driver to send print jobs. Device scheduling, the OS manages multiple devices, prioritizing tasks. For instance, when printing a document while playing music, the OS schedules the print job after processing the music playback. Device allocation allocates devices to processes. For example, when you insert a USB drive, the OS assigns it to a file manager for use. Device management ensures efficient device use, providing smooth interaction between hardware and software. File management in an operating system is responsible for organizing, storing, and accessing data on storage devices like hard drives and SSDs. It ensures that files are stored efficiently and can be retrieved easily. Key aspects of file management include file organization. The OS organizes files in directories and folders, creating a hierarchical structure. For example, when you save a document, the OS stores it in a folder like Documents. File access. The OS defines methods for accessing files, such as reading, writing, or executing. For instance, double-clicking a Word document opens it, allowing you to edit its contents. File security. The OS manages file permissions to control access. For example, you may set a file as read-only, preventing others from making changes. File storage. The OS allocates space on storage devices for files and ensures efficient use of space. File management ensures that files are organized, accessible, and secure. Apart from process, memory, file system, and device management, an operating system also offers several other important features. Security. The OS ensures system security through authentication, encryption, and access controls. It protects against unauthorized access and malware, like when you enter a password to log in. User interface (UI). The OS provides a way for users to interact with the system, such as through a graphical user interface, GUI, or command line interface, CLI. Networking. The OS manages network connections, enabling communication between computers, like browsing the web or sending an email. Error detection and handling. The OS detects hardware or software errors and takes appropriate action, ensuring system reliability. These features enhance usability, security, and stability in an OS. The properties of an operating system, OS, define how it functions and interacts with hardware and software. Key properties include multitasking. The OS can run multiple processes simultaneously, like browsing the web and listening to music at the same time, by allocating CPU time efficiently. Multi-user capability. It supports users accessing the system concurrently, like a server hosting several users' accounts. Portability. The OS can run on different hardware platforms with minimal changes, such as Linux running on desktops, servers, or mobile devices. Scalability. The OS can handle increased workloads by scaling resources, like adding more RAM or CPU cores to a system. Reliability. It ensures stable and consistent operation, minimizing crashes or errors, essential for tasks like banking or medical applications. These properties ensure the OS is versatile, efficient, and reliable.